Okay, well, in the last video, we talked about logic gates. You know, you got your NOT gate or inverter, your AND gate, OR gate, XOR gate. But I wanted to kick it up a notch with this one. So we're going to talk about this guy here, which is the 74LC595 shift register. And what this thing does is, internally, it's got 8 bits of memory here, just like that too. And basically the idea here is that you can give this chip ones and zeros as information. Not that much different than how we gave ones and zeros to our logic gates. And it's going to give you some kind of output as a result. And for this guy, what it does specifically is we can give a 1 or a 0 on the serial pin here, and it's going to fill up this memory that it has, so it can hold on to up to 8 different values. And our outputs here, we have 8 outputs, actually 9, but we'll get back to this one in a second. And these other pins here are also inputs, and they help us talk to the chip. So let's say we want to send a 1 or 0 to this chip. Well, it requires telling the chip that you wanted to give it information in the first place. And that's what this shift register clock pin is for. It's kind of like a walkie-talkie. Hold it down, then we can send a 1 or a 0, then light off it again. Or like a push-to-talk. This other pin here is the shift register clear, which will just blank out whatever's already in there. Just erases everything. And this R clock, what's interesting about this circuit is that, or not the circuit, this chip I suppose, is that it's got 2 8-bit memories, I guess. Whatever you put into the input will not immediately go to the output. The output is a separate deal here. So the output will stay the same even if you're giving it new information until you the register clock here, which copies everything that's up here from our input. It copies it all to our output memory, I guess you would say, which is useful. And then finally down here, we've got the OE, which is output enable. There may be times where you don't actually want this thing to give you output, so you can turn that on or off. Most of the time you'd want that on. But there might be some applications that people can think of where it would be useful to turn that off temporarily at least, and then turn it back on. So what do I mean? What is a shift register in the first place? What's happening here? So imagine this guy up here. This is our input, and it's just all full of zeros right now. Okay, so I send it a 1. And then all the rest of these things will end up being zeros all the way across. And all the input comes from the right and shifts to the left. So if I give it a 0 the next time around, 0 this time, what's it going to look like? It's going to be 0. This 1 got shifted over one, like this. And everything else gets shifted to the left by one spot. Now, let's see what happens if I have something like, let's just make up some random weird number here that's already in here. I don't know. I just pick anything. Imagine that's already in there, and now we're going to send it a 0. So what's going to happen? Well, 0, that's what we're bringing in here. Then we got 1, 0, 0, 1, 1, 0, 1. Everything got shifted over by 1, which is why they call it a shift register. But what happened to this other one? It got shifted out, and well, that's not in here anymore. Where'd that go? That's equivalent to, well, this thing here. This is our 8 spots. Goes over to the 9th one. What happens? We also have this QH prime pin here, and that will actually push that out as output too. So this one is getting shifted over, gets shifted over to this guy and out. Depending on, you might care about that or not, but it's there if you want it, which is useful because what that means is you can chain a bunch of these together, and instead of just having an 8-bit register, you could make it a 16 bits, a 24-bit, 32-bit, etc. So you can hook more. All this means is that you can hook more than one of these things together. So that's pretty good. So how does it work in practice, though? Let's take a look at that. Remember, I said that you can control your input clock or your independently of your display. So you could put a whole bunch of stuff in here. It's not going to show up on your output until you hit the register clock here, which is, that's going to pull all of this stuff down that was in here or in here. All that's going to go into here, which is the output. And so this is a circuit that does exactly that. Oh, hang on a second, we better have all this actually hooked up right here. It's kind of hard to do with holding the camera. There we go. And this is just whatever happened to be in the register already. And this is just wired up the same way. You might notice that the way I have it laid out here is not the same as it would be on the board here. And the reason for that is I specifically drew it this way to make it a little easier to see. The actual pinout on the chip is a little bit different. And the computer just died. Yeah, I wish I was going to show you here, but let's get back in there for a sec. On the data sheet, you'll notice the pinout is different than what I have over here. And this is the actual data sheet, and so this is what the actual pins out are. And what I have here obviously reflects what it physically does. We've got all of these outputs on the one side, and then the ground, and then this way over here we've got an input to this QA, and that's what we see down here with these white wires. Not this one, but all the rest of them. And that's what that is. And so, okay, so I've got LEDs hooked up to each of the outputs, and I've got some buttons here. I've got one for my inputs, my serial in. I have a button for the clock, and now it's actually tied to both the shift register clock and the register clock. So these are hooked together. So when I input something, it will also give me some output as well. And it's off by just one step. That's what the spec says. That is what it does. And then finally, I've got this other button here on the end that is the shift register clear. That'll just clear everything out and send it back to 0. So let's do that first. So I'll hit the clear button. Notice it doesn't do anything until I hit the clock. Then it shows that it's cleared everything out there. So I can hold the data button and hit the clock. Maybe one more time. And these buttons bounce a little bit, so sometimes you'll get more than one input for that, and I'll talk about that later. But the basic idea here is, though, that then I can just keep feeding this thing zeros by just hitting the clock, and you'll see that it moves along. And every time I hit the clock, it's shifting over. I'm feeding it a bunch of zeros. So it's just like this thing here. This top part, we started off with zeros. I gave it a 1. And then we're just clocking it over with more zeros, more zeros, more zeros. So this 1 just keeps moving along. And that's exactly what we would see with this. Now, like I said, you can hook a bunch of these 595 chips together, and we'll take a look at that in the next video. But that's kind of the basic idea of what's going on there. This can be used for all kinds of stuff. I've seen some creative uses for it that I'm quite sure that the engineers that came up with this in the first place had no idea somebody would do. But this is a very useful and versatile chip. You could use it as memory in a small computer. You can use it for a whole bunch of different stuff, and we'll investigate that in some of the next videos.